All right, welcome back to Miss Lastly's videos. Today we are doing, oh my goodness, hold on. It's not day 5. It's day 6. Okay, quick fix. Okay, so it is day 6 and we're going to be graphing secant and cosecant. We're going to look at the steps for graphing these, which they're actually super simple. And then we're going to do a practice problem. So this should be a pretty quick video. Again, for me, what does quick mean? Nobody really knows. I am super long-winded. You probably are really sad that it's me now instead of Miss Marker because I know she doesn't talk as much as me. But anyways, you can always fast forward through the videos because it's on the internet. At least you don't have to listen to me in class, right? Okay, here we go. All right, so for graphing cosecant and secant, so usually when we've done these trig functions, we've looked at a table of values to kind of get the original graph. We don't need to do that for this one because really what we're going to be doing is graphing sine and cosine. So nothing super new. Yes, we're going to end up with a graph that looks very different, but truthfully, if you can graph sine and cosine, then you can graph cosecant and secant. So this is what you first do. So this is steps. So instead of a table, I'm just going to give you the steps for how to do this. Step 1. For cosecant, you are going to graph the sine function given. Graph it as if it was sine. All right, so graph the given equation using sine. All right, so ignore the cosecant in there, graph it as if it was a sine function. Step number 2, all right, and think about this. Okay, so step number 2 is everywhere sine is 0, draw an asymptote. And if you think about it, right, when you're doing cosecant, since it's the reciprocal, meaning flipped, right, version of sine, if sine is 0, then cosecant is 1 over 0, which is undefined. So the second step is draw an asymptote, when sine equals 0. All right, so everywhere you cross that midline or you have 0, draw an asymptote. Step 3, this is the last step. Invert the graphs. The graph sections. All right, invert means to flip it upside down. Oh, hold on one second. Okay, so sorry, I had to step away for a second, so I forgot exactly what I was saying, but you invert the graph sections. Excellent. Okay, so let's just do it. So what we're going to do for graphing cosecant of x is we're actually going to graph sine of x. So that's our first step. So step number 1, I'm just going to go ahead and doop-a-doo. There we go. And I'm going to do my same values I would do for sine on my axis. So we'll do this one in degrees. So I have 0 degrees. We got 1, 2, 3, 4. All right. So this is 90. This is 180. And this is 360. All right. So there's one full period for our sine graph. And then usually we go up 1 and we go down 1. All right, so here's my sine function. Sine starts at 0 and then it goes up, down, down, blam. So here's sine. Bloop, bloop. All right, so there's one period of sine. Now what we're going to do, so check. We did the first one. Graph the equation using sine. So we graphed cosecant of x using sine. Step number 2. Draw asymptotes where you have sine equaling 0. So everywhere we cross 0 or our midline, which we don't have any kind of midline shifts, so we just do it everywhere we cross 0, we're going to draw an asymptote. So we have an asymptote there. We have an asymptote right here. And we have one, oh my goodness. Hold up, guys. I forgot 270. 270 and then 360. There we go. All right, and then we do one right here. Okay. Whew. There we go. All right, so next we have, oh, I got rid of my graph because I had to erase it. There we go. There's our sine graph. I don't know why I forgot 270. Bad job on me. All right, so everywhere we cross 0, we draw in an asymptote. That is step 2. Step 3, invert the graph sections. So between every asymptote, you're going to invert the graph sections. So that was I did in blue. So we did the last one in purple. All right. So we're going to invert. So right here, that first 0 to 180, it's an upside down U. We're going to make it a right side up U. So we're just going to invert it. We just flipped it upside down. We're going to go to the next section of the graph and we're going to do the same thing. It is up facing U. We're going to flip it upside down. There we go. Now, we can check this off. Guess what, guys? We're done. That purple graph, this piece right here, and this piece right here, that's your cosecant function. That's your cosecant graph. It just takes all the little U pieces of the sine function and it just flips them upside down. That's it. So you have asymptotes starting at 0. And then every 180 degrees or every pi. So 0, 180, 360, right? And it would go on, add 180. Every extra 180, you're going to have another asymptote. That was easy, right? That's super easy. Guess what? It's exactly the same for secant. So for secant, same steps. Step 1, instead of graphing using sine, we're going to graph using cosine. So graph cosine of x. Step 2, draw asymptotes where cosine x equals 0. Step 3, invert the graph sections. And that will give us our secant graph. So let's go ahead and sketch out our cosine graph. So step 1, graph cosine of x. All right, so cosine, so we have our up 1, we have our down 1, and we have 1, 2, 3, 4, 5. Okay, and now we're going to label. So I'm going to do this one in radians. So we have 0, we have pi over 2, pi, 3 pi over 2, and 2 pi. Why did I do an extra one this time? I did one less last time and one extra one this time. Oh well, okay. So now we're going to step 1, graph cosine. So cosine starts up at positive 1, and then it goes to 0, then negative 1, then 0, then positive 1. So here's our cosine graph. Check. Graph cosine of x. All right. Step 2, draw asymptotes everywhere cosine equals 0. So this is going to be different than it was for sine because sine and cosine have zeros at different places. All right, but this one is going to be at pi over 2. So we have one at pi over 2 and we have one at 3 pi over 2. All right, so check. We drew in our asymptotes. And step 3, invert the graph section. So each section of our graph, we're just going to flip it upside down. So this one looks a little bit funky because it's not as beautiful as the sine graph because it doesn't have like exact like sections, right? Our asymptotes are kind of in the middle of our graph. But all you have to do is upside down it. So for the first section, we just upside down it. So we just take that half of a parabola and flip it upside down. In between, it's a nice perfect one. So we just flip it upside down. And then on the outside piece, we just flip that upside down. So you get this. So check. So guess what? That purple part, this piece right here, this, that's our secant graph. Cool. That's it. That's all I gotta do. So if you can graph sine and cosine, you can graph cosecant and secant. All right. So we're going to do one example problem. And, so we have, I forgot to fill in the asymptotes. We have asymptotes at pi over 2, 3 pi over 2, and then every pi you're going to have another asymptote. But you don't need to remember that. It's not really that important because you're going to find it where your graph crosses the midline or when cosine is 0 thing. Okay, let's do this practice problem. Man, I am hungry. Okay, I'm glad this is our last one because I'm going to go eat some food afterwards. Okay, Okay, so graph the given trigonometric function and find the indicated information. I only did one because I think once you get the idea, you don't really need to do both. Like I said, if you can graph sine and cosine, you can graph secant and cosecant. The techniques are exactly the same. So this one happens to be a cosecant function, but if this was secant, again, you could do the same thing. You could do it. I have faith. All right, so let's pull out our b value first. So first I'm going to go ahead and rewrite this with my b value pulled out. So this is 3 cosecant 1/2 x plus 180 minus 1. Ooh. Remember, you're taking 90, you're dividing it by 1/2 because you're pulling out 1/2, and that should give you 180 because it's like multiplying by 2, right? Okay, so here's what I'm graphing. All right, now I'm not actually going to graph cosecant. I'm going to kind of ignore that to the very end. I'm going to graph this as if it was the sine, because cosecant is the reciprocal of sine. All right, so I'm going to graph this as if it was a sine function. So I kind of ignore cosecant. I just write sine over top, and I'm just going to graph it. All right, so my a value, 3, my b value, 1/2, my c value, I'm going left, 180. My d value is down 1. All right, my period is, so we are in degrees. So it's 360 divided by my b value, which is 1/2. So this becomes 720. So my period is 720. My midline is down 1, or you can say y equals -1. All right, and then I'm going to fill in asymptotes later because I'm going to do it once I graph this bad boy. So we'll get asymptotes at the very end. All right, so I'm just kind of letting it catch up because the writing is a little bit behind what I've done so far. Blue. Come on. Catch up. Catch up. It's the internet. It's a little slow in this corner of the house. Okay. So I'm just going to sketch my graph. Now again, I am a lazy grapher. I don't really care that I'm going left 180 degrees. I'm still going to draw my graph starting like it looks like it's at 0, 0. But remember, I'm labeling everything. Okay. So I do 1, 2, 3, 4, 5. This is my midline. Okay, so my midline is at -1. So this right here is -1. I know it looks like it's at 0, but it can be whatever you want it to be as long as it's labeled. All right, and then my amplitude is 3, so go -1 plus 3. That's going to give me +2 for my max, and then -1 minus 3, which gives me -4 for my minimum value. All right, and then I know that my first point of my graph is left 180 degrees. So I'm going to go ahead and label that as -180 degrees. All right, now to find all of my other points, I'm going to take my period of 720 divided by 4 because I'm moving 4 places on my graph. It's so slow, the writing catch up. I'm sorry. So I'm going to take my period of 720. I'm going to divide it by 4. And that gives me, because I'm not a magician, 720 divided by 4, 180. That gives me 180. So that means I'm going to start at -180 and I'm going up by 180 each time. All right, so -180 plus 180 is 0. All right, and you can do that with your calculator. The writing is slowly catching up. So I have -180 plus 180, that's 0, plus 180, that's +180. Plus 180 is 360, plus 180 is 540. All right, so that should be where my period ends. Another way you can check this is we are starting at -180 and I have a period of 720. So I'm starting at -180, I have a period of 720. This should give me 540 if I've done everything correctly. So -180 plus 540 does give 720, sorry, 180 plus 720 does give me 540, which is what I got when I added my increments each time. All right, so I will let it kind of catch up now because I'm going to go into the actual graphing piece. But yeah. right, so here, just to kind of follow what's actually getting written on there. So I'm taking 720, I'm dividing it, which is my period. I'm dividing it by 4 because I'm adding something equally 4 times to get my points on my x-axis. All right, so 720 divided by 4 is going to equal 180. So that means from my starting point of negative 180, if I add 180 each time, it will give me the points that I need for my graph. Oh, I'm telling you guys, this stool is super uncomfortable. All right, I'm just gonna pause it. You guys won't know that I'm pausing it, but I'm just gonna hang on. Okay, all the writing got caught up now, so I can go ahead and graph. Just recapping. All right, so the 720 is my period. I divided it by 4. I got 180. 180 is what I'm adding each time to get all of my points on my graph. And then I wanted to double check my answer. So negative 180, which I know is my starting point because I have plus 180. So my phase shift is 180 to the left. So I'm taking the negative 180, I'm adding my period, and I did end up with 540. So that is telling me that's one period of my graph. All right, so it's just me double checking. All right, so now I'm going to go ahead and I'm going to graph this as a sine function. All right, so I know sine starts up at, nope, it starts at 0. So sine's at 0 and then up, back to 0, down, and then back to 0. All right, and then I connect my dots. All right, and that's going to give you my beautiful sine function. Okay, so the next thing that I have to do is everywhere sine is 0 or crosses the midline, I'm going to go ahead and I'm going to sketch in my asymptotes. Okay, so now I have all of my asymptotes. So now I can go ahead and fill in that last line over there, which is what are my asymptotes. So I have one at negative 180, positive 180, and 540. Now, if you want to double check to make sure that your asymptotes are in the correct place, it's an easy check. All right, so you want to go to your calculator and you just want to make sure that you get zeros when you plug in these values for x. And I'm going to do it with sine since we don't have a cosecant button on our calculator. All right, so if I type into my calculator 3 times the sine parentheses of 1/2 parentheses, and let's do the 181. So 180 plus 180, close parentheses, minus 1. I should end up with the point negative 1. If we're in the correct mode, which we should be in degree mode. 3 sine of 1/2, and then 180 plus 180, close, minus 1. And we are at minus 1, right? So sorry, the first one I did radians, so that's why it gave me a decimal. So I typed it in, I substituted in 180 positive for x, and it got me negative 1, which is my midline, which is what I got here. And then remember, since cosecant is the reciprocal, if it's 0 for sine, then we know that it's going to be undefined or an asymptote for cosecant. All right, the last thing we have to do is to invert our graph. Don't forget this part because the answer is not the graph of the sine function, it's the inverse of the sine function. So we're going to go ahead and we're going to invert our graph. All right, and there we have our cosecant graph. So that blue section, right? Maybe I'm going to highlight it a little bit just so you guys get the, remember, it's not the sine piece that's the graph, it's the blue part that is our cosecant graph. So you graph sine, you sketch in the asymptotes everywhere sine crosses the midline or has a value of 0, however you want to think about it, and then you invert those sections of the graph. All right, so that blue piece, that is the actual graph. So you don't need the pink part. All right, so if you don't want to draw that part in, you don't have to. Some people do that as a dotted line. Since I have colors in OneNote, I like to use the colors to like make them differentiated. But if you're doing this with pencil or a pen, you can just do like a dotted line for sine, and then the cosecant part of the graph you would do like as a solid. All right, so that is it for this video. Hopefully that helped you guys draw your secant and cosecant graphs. And if you have any questions when you're going over the homework, we'll answer them in class the next time I see you. All right, bye guys.